Now that we have all the components routed and all the lines that connect to one another taken care of, what we need to do now is to actually define the extents of our board. So to do that, what we need to do is we need to add two things. One is called a board outline and another is called a photo plot outline. Excuse me. The way that you do that is you go to outline and then you go to board. This allows you to add a board outline, and you see that the dialog that opens up has a create in it, and the board edge clearance that you want to keep is at least 0.254 millimeter according to the manufacturer. So you put a 2.254 in there, and then what I do is I come here and I start drawing a rectangle over the board. Now remember that this particular power connector that we have, this power connector needs to be flush against the side of the board because you are going to plug in the jack from the wall socket. So remember those kinds of things. If you put it inside the board, then that jack is not going to fit because of the plastic enclosure. So things like the barrel connector, things like USB connectors, etc. should be flush against the edge of the board. So to do that, what I do is I make the board outline start from exactly the edge where the connector is, and then draw a rectangle all around the board. So there I have it. That is my board outline, and you see that these little things come in against the lines, and using those later on we can edit the particular board. So now we do an apply and close. So that is our board outline, and if you zoom in, you would be able to see that there's a board geometry outline and there's a package keep in, which means that this is the line within which all of the packages must be in. And also what you see is that because I keep one of the parts flush against the board, there is a DRC error that is generated, that red little thing that indicates an error. But then since this is the way that the board has got to be designed, we ignore it for now. So that is creating the board outline. Now mechanically speaking, you may also want to add holes at the edges of the board so that you can put in things which are called hex standoffs, so that your board doesn't lie on the desk but it actually stands on 4 supports. Now you can automatically do that, and the way that you do that is you go to place and you go to components manually. Then what you do is you select this drop down and select mechanical symbols, go to advanced settings and enable the library view, go back to placement lists, and now mechanical symbols will be a drop down by itself. You drop it down and you can choose any one of these 3 mounting holes which are there. Now a mounting hole with 125 mils diameter is good enough for the hex standoffs to go in, so we will use that. And then what we will do is we will place 4 of them on the board. So let us place it near the edges of the board. So let me place one here, then so that is there. And then what else? Now let me try doing it flush against the side of the board. So what I'll do is I'll try placing it right there. So maybe a little bit inside, so you can always hold the control key and zoom in to see where you are placing this. So what I did was I placed it basically 1 grid away from the edge. Let's just do it against the edge. Okay, so that is 1 mounting hole there. Then I can choose another one, and that I'll place in the other position. So let me zoom out and move with it, and then place it right there. Then and similarly for the other corners, of course. There. So I have 4 mounting holes now on my board, which I can later use to plug this board into the hex standoffs and make it stand. So that's about putting an outline on the board, the hex standoffs, and also keeping in mind that connector like components should always be flush against the side of the board, even if that generates DRC errors. So we save the design, and then in the next video what we are going to see is how to put in dimensions on the design.